Howdy, friends! Let's talk about everything you need to know about day, night, and seasons on Earth. First part about this is why we have day and night. It's actually the easiest part. Day and night on Earth is caused by Earth's rotation. Rotation is the movement of an object around a central axis or a central point, and the Earth has that. The Earth has an axis, and it rotates on its axis, causing day and night. The side of the Earth facing the sun is experiencing day, while the side of the Earth that doesn't face the sun is experiencing night. And as it rotates, the parts of the Earth that are experiencing, that are facing the sun or not facing the sun, change. And you should know this by now. It takes about 24 hours or 1 day for the Earth to complete one full rotation. And the lines in the middle, that day-night line split here, that's where sunrise and sunset happens. The Earth also rotates counterclockwise. It means it goes to the left. So this is why we see the sun, quote unquote, rise in the east and set in the west, even though the sun doesn't move. We are moving. So it appears that is moving from east to west across our sky. Now, seasons are a little more involved. Seasons change because of Earth's tilt and revolution. Yes, the Earth continues to rotate during this process too, but that's not what causes seasons. Seasons are caused because the Earth's tilt on its axis is at a 23.5-degree angle, and it revolves or moves around the sun. Because of the Earth's tilted axis, this means that Earth receives uneven distribution of heat energy from the sun in each hemisphere. This is a really big deal because this uneven heat distribution creates the differences in seasons between the hemispheres. Remember, we did learn so far that the hemispheres, the northern and southern hemispheres, are the two halves of the Earth. Everything north of the equator, my green line here, is the northern hemisphere, and everything south of the equator is the southern hemisphere. Whenever any hemisphere, north or south, is tilted away from the sun, that hemisphere is receiving indirect heat energy. Notice how of the half of the Earth lit up on the receiving day, there's not a lot here that's actually in the sunlight. Whenever the hemisphere is tilted towards the sun, it's receiving direct heat energy. And I also noticed that of the side of the Earth lit up, the northern hemisphere here is getting the most heat energy here. So whenever it's tilted away, that's in the receiving indirect heat energy. Whenever that happens, we're experiencing winter. Whenever the hemisphere is tilted towards receiving direct heat energy, that season is summer. Now, there are points in the revolution around the sun where the Earth is not tilted towards or away from the sun. And at those points, the Earth is receiving equal amounts of heat energy distribution across the hemispheres. And during those points, fall and spring are happening. Now, because the Earth revolves around the sun while it's being heated unevenly, this causes seasons to change. So if Earth didn't move around the sun, but it was still tilted, we would just kind of be stuck in one season all year long. But because it moves, we experience changing seasons. So we go from summer to fall to winter to spring and so on. The Earth revolves around the sun just like the Earth rotates, counterclockwise. So it moves to the left, and it takes about 365 days, or about a year, for it to complete one full revolution. Technically, it takes 365.25 days, and that's why we have leap day every 4 years. That's more than you need to know, though. So let's talk about heat distribution at each of these points in our path around the sun, and what seasons will be occurring in each hemisphere at each point. So here we're going to start on June 21st. June 21st is, well, something to note is that the date stays the same in both hemispheres. It's not June 21st in the northern hemisphere and December 21st in the southern hemisphere. It's June 21st all around the world at this point. But the difference is going to be in seasons because of the Earth's tilt. I notice here that my northern hemisphere is tilted towards the sun, but that my southern hemisphere is tilted away. Now, if you remember from heat distribution and what it means to be tilted towards or away, the northern hemisphere being tilted towards means it's getting direct heat energy, which means the northern hemisphere is in summer at this point. The southern hemisphere is tilted away, which means it's getting indirect heat energy, so it's in winter. So keep that in mind. Southern hemisphere, first day of winter, is actually June 21st. So I'm going to continue my leftward motion, my counterclockwise motion, and I'm going to move on to September 21st. So on September 21st, the Earth is neither tilted towards nor away from the sun. It's kind of parallel with the sun at this point. I see it all dark here because I'm looking at the back of the sun. So I'm seeing the night side of the Earth here. At this point, when neither hemisphere is tilted towards or away, it's either fall or spring because the heat distribution is equal across hemispheres. So I determine my seasons based on what came before. And what came before for northern hemisphere was summer, which means northern hemisphere is going to be in fall at this point, and southern hemisphere will be in spring. Continuing on, December 20th, I noticed that now my northern hemisphere is tilted away from the sun, which means the northern hemisphere, where we are, is receiving indirect heat energy, which means it's winter here, and now it's summer in the southern hemisphere because they're tilted towards and receiving direct heat energy. So summer starts on December 20th in Australia. Can you believe that? Then moving on to March 21st, again, the Earth is parallel almost to the sun, so we're not tilted towards or away in our revolution around the sun, which means it's either fall or spring. And remember, I go based off of what happened before. So if the northern hemisphere before that, the season before that was winter, that means the next season is spring, and the next season for the southern hemisphere is fall. And then it just moves on. So let's talk about a few hypothetical situations. How could you increase the length of time between seasons? What would happen if the Earth weren't tilted but still revolved and rotated? Pause the video, think about it, and then hit play again whenever you want to see if you were right. Let's see. So you could increase the length of time between seasons by making the revolution longer. You could also and then what would happen if Earth weren't tilted but still revolved and rotated? You wouldn't have changing seasons. So if we were stuck in this position all year long, we would be in eternal summer. Unless we were in the southern hemisphere, then we'd be in eternal winter. I don't know which I'd rather like better. So one more thing to talk about with day and night and seasons. Because of the Earth's tilt and revolution and the rotation of the Earth, this means the angle of sunlight changes throughout the year. And you might have noticed that in the winter, the sun doesn't stay out as long, and in the summer, it stays out all day long. Stays out a long time. The sun doesn't set till like 8 or 9 o'clock at night. This is because the tilted axis and the revolution of the Earth causes the length of days to change throughout the year too. I'm going to give you some diagrams to help you kind of visualize this. So in January, the sun, this is northern hemisphere, the sun doesn't get very high in the sky because we're tilted away from the sun. But as we become more tilted towards the sun in our revolution around the sun stays higher in the sky. When it stays higher in the sky, or when depending on its position in the sky, we receive different angles of light. So in the summer, the sun is more overhead, so the angle of light is more overhead. This leads to longer days and warmer temps because the heat energy is more direct and it stays longer in the sky, so it's longer amounts of light. In the winter sunlight, which would be January here, the angle of the sun is lower in the sky, or the sun is lower in the sky, which means the angle of light is lower, which means it's going to be shorter days and cooler temps because it's more indirect energy over a larger area. So let's combine this with seasons and what it looks like in our path around the sun. Whenever the sun is tilted, or whenever the hemisphere is tilted towards the sun, this is what the angle of light is looking like. Whenever it's tilted away, it's winter, we're getting shorter days and cooler temps. In the fall and the spring, I mentioned that heat energy distribution was even, and that's because the angle of sunlight is also equal in each hemisphere as well. In winter, it flip-flops. So whereas before the northern hemisphere was getting the direct energy here, the higher angle of sunlight, now we're getting a lower angle of sunlight, which leads to shorter days and cooler temps for us. And then spring, same thing happens. And it just continues like that. See that the angle of light just keeps changing based on the position of the Earth in its revolution around the sun. That's it. That's all that I have for today. If you have any questions, just message me and I'm happy to help you. Hopefully this helps clear things up for you and gives you a good summary of everything you need to know. I'll talk to you guys soon.